we're just about ready to start. Can you hear me? Can you hear me? Yes. Okay. I want to thank you all for coming. It's really good to be together these times after the COVID. It's lovely to see this room starting to fill with people. I know I gave you an information sheet that you got at your tables, and that could be kind of daunting. If you read that, you might think of Jerry as a stoic, solid, not very friendly guy because he's so busy doing things. But fear not, it's not Jerry. The Jerry you're going to see tonight is the one you will learn to love, I know. It's just our pleasure to welcome you here tonight, Jerry. It's not a happy topic, but we need to hear it from someone like you. So please give him a warm welcome.
Thank you. Thank you. Keep that on. I got another one. It's really nice of you to be here. I have lots of friends in the audience. Joyce Carmen taught both of my kids, Ben Schoor and Billy Schoor, civics or government or one of those, and they told me that she is the best teacher they ever had. So I'm pretty lucky to be introduced by Joyce Carmen Baldus. And Dave Baldus, her husband, was an excellent friend of mine too, in faculty senate at the University of Iowa. And we worked quite closely together. I came to know and love him also. We're going to talk about climate change, but I thought rather than talk about the effects and the derechos and the tornadoes and the wildfires and the sea level rise and all that, you know all that, and let's try to keep it a little more positive. And what are the prospects for dealing with this very important problem that we call climate change? So that's the gist of what we're talking about tonight. This is the planet Earth that we're trying to protect. Basically what has happened to us is we've used the atmosphere as our exhaust pipe to accumulate all the gases. Yes?
Could you turn your mic up just a little bit?
Sure. Well, I think I can. Let's see, is this up? Is this one up? Okay. Sorry.
No, it's okay.
Is that a little bit better? Okay, thanks. Thank you for that. So it's kind of a top-down warming that we're experiencing because the atmosphere is such a small compartment reservoir. Really, you know, it's held, this is about maybe at most 50 miles thick, held onto the skin of the Earth by gravity. That's what keeps our atmosphere there. And when you use it as an exhaust pipe like we have, because it's rather small, it's easy to begin to change the concentration of gases in that thin veneer around planet Earth, and that's what we've done. So it's a top-down warming starting in the atmosphere, but then, lo and behold, I would have never believed this when I was a student that we could warm the oceans in my lifetime, but we have done it. Very clear signal, the surface of the oceans are about 1 degree Fahrenheit warmer. We can see the heating signal down 2,000 meters and more in the ocean. And what's more, as you know, we've also acidified the oceans too, which is because carbon dioxide, the main greenhouse gas, is a potent, well, it's a weak acid as we call it, but when it transfers into the ocean, and it causes the ocean to become acidic too, causing problems for coral reef, the base of our food chain. It's kind of a dangerous experiment we're running. But I thought tonight I wouldn't talk too much about the effects, but rather our prospects. And our prospects are good. At least it could be good. Yes?
Could you turn your mic up and down a little bit?
Sure, now I think I know how to do it even. I'm learning. Let's see. Oh, maybe I don't. Am I handheld? No, I'm the headset mic one. Lavalier mic. Okay, that's maximum now. Is that the Goldilocks just about right?
It's too loud, it starts to echo.
Okay, thank you. So that's the story, and what are our prospects for dealing with all those changes? Last bit of bad news, and that was that there was a report issued. It's the 6th one in a series. The first time I taught about climate change was in 1990. That was the first report. This is the 6th report called AR6, the 6th report in a series. And each report has gotten more and more sobering and more compelling in terms of the certainty. So now this report done by literally hundreds and almost 2,000 scientists all together. There's 3 volumes to it. This was the one in the fall. Is really quite an amazing report. They use words like unequivocal, that human influences warm the atmosphere, ocean, and land. Widespread changes everywhere: atmosphere, ocean, cryosphere, biosphere. We've never had carbon dioxide concentrations as high as this in at least 2 million years. It might be about 50 million years. Keep in mind, humans have only been around, well, we had 3 Homo, we're the only species of our genus in the world, Homo sapiens, but before us was Homo erectus and Homo habilis. Homo sapiens really have evolved since about 200,000 years ago. So never in the history of humans has there ever been a situation like we're experiencing right now. The carbon dioxide was never so high. And in fact, other greenhouse gases that are important, like methane and nitrous oxide, so-called laughing gas. Your dentist might have used this on you at some time or another. Laughing gas, we know for sure that they've never been higher in 800,000 years. So we're really doing an experiment that has never been experienced by humans, and humans have evolved in an atmosphere, in a climate, much, much different than where we're heading. So now the prospects. We have some good news. The Biden administration and our Energy National Policy is trying to address many elements of this problem. The bipartisan infrastructure bill has passed, as you know, $2 trillion. The Build Back Better bill has not passed. We'll talk about both of them a little bit this evening. Build Back Better includes more charging stations for electric vehicles. I saw some in your parking lot. Batteries and materials manufacturing, and vehicle manufacturing, electrical vehicles. We'll talk about that and more. All of that means high quality, high paying, fair living wage jobs. It's the engine for economic opportunity and development in the future. It's how my students and their children are going to get jobs in the future. So this really is a good news story if we play it correctly. Biden says that we should have 50% electric vehicles by 2030. That'll be hard. We're only at about 6% right now. The federal government counts both plug-in hybrid electric vehicles and battery electric vehicles. So it's got to have a plug on it in order to count. And I'll show you, we've had quite some improvements in our power plant regulations recently. Our mileage standards for our cars and trucks, and a lot of other developments have been quite good. The bipartisan infrastructure bill, which passed, adds more charging stations. We need a lot more if people are actually going to overcome their range anxiety and get a charge in a reasonable amount of time on a longer trip. And it includes 500,000 new charging stations, $5 billion to the states to build a national charging network. They're going to concentrate on certain routes that they know are used a lot, like St. Paul to St. Louis, the Avenue of the Saints will have a lot of charging stations along it. There's about $2.5 billion in there for communities to develop charging stations like this shown here on the right. There's a blueprint for lithium batteries. We don't have much lithium in our country. We're buying it from Canada and Chile and other places. So we need more lithium mining. We need to recycle the batteries better than we're doing now. You may know that the hybrid cars have a nickel metal hydride battery. Nickel is an issue because it's a strategic material that we only have one mine in the Upper Peninsula of Michigan right now. Actually, my students are working on another story, another talk. Plants that hyperaccumulate nickel from wastelands, from old mine sites, and then we harvest the plants. We turn them into biochar. The plants have concentration of nickel in them greater than any iron ore, any nickel ore anywhere in the world. We turn it into biochar, and now it's a really cool electronic material. We're painting electrodes with it now, carbon and nickel for supercapacitors. We think the next generation of electric vehicles will use supercapacitors rather than the battery technology that we're doing now. But that's a whole nother story. Also, advanced vehicle technology manufacturing is included in that. I have a link here, maybe you can go to it later, but of the Shanghai Tesla plant. Even though I said we're going to have millions of high quality green jobs, there's not too many people in this video when you watch the video of the new Tesla plant. There's another one coming online in Berlin now, and there'll be more. There's one going to be in Austin, Texas, Nevada, California, Ontario, and a new one to be built in the eastern half of the United States. Lots of high quality jobs as a result of advanced vehicle manufacturing. Some other good things. We already mentioned that the goal is 50% of all vehicle sales. We're at 6% right now. The Traffic and National Highway Safety Administration, we're at a mileage standard by 2026 in just 4 years. That's actually intermediate. The Obama administration had a higher mileage standard set. The Trump administration lowered it greatly, and now we've kind of raised it up, but we have lost some time. Still, 52 miles per gallon by 2026 would be a marked improvement over what we have right now. This is a metric I teach my students. I don't know if you're familiar with it yet or if it comes up at dinner time, but it's the grams of carbon dioxide per mile. We won't talk so much about miles per gallon in the future. We'll talk about grams, mass of carbon dioxide emitted per mile. And for electric vehicles, that's entirely dependent on how they fill their battery. And if the fuel mix involves coal-fired power plants, it's still not acceptable, still not good. But we here in Iowa are actually pretty advanced in that we're about 65% renewable power now. Mid-America's got a goal of 100% renewable power. So when we fill our electric vehicles, the storage battery, we're filling it with renewable energy, basically. And even the batteries will be an important part of the story, the good news story I'm trying to tell you tonight. We have 240 million cars in the US. That's more than driver's licenses that we have in the US. We have more cars than people who have driver's licenses. If you had a storage battery in every one of those 240 million cars, you'd have 660 gigawatts, billion watts of storage available. Then we have a smart grid. We hook up the cars. At night, we fill them up with power that's cheap because not much demand in the middle of the night. And during the day, we can shave off the peak by parking your car at work and putting some energy back into the grid. We call it V2G, vehicle to grid. And so cars will become an important part of the way that we store intermittent solar and wind power. But we need a better grid in order to do that. That's part of the infrastructure and jobs that we're talking about, including in these infrastructure bills before Congress right now. The recent news on mercury and air toxics, which extremely toxic and neurotoxin, especially for kids, much like lead, causes developmental disabilities. We have new rules on that, estimated to save on the order of 4 or 11,000 lives annually. And the costs calculated by the administration are $90 billion more benefits than the cost of implementing the new air toxics rules. More good news, there's an infrastructure program to try to cut leaks and flares, like you're seeing here. This is the fracking in the Bakken Formation in North Dakota, if you're familiar with it. And there's lots of leaks from drilling, horizontal drilling for fracking and horizontal drilling for oil and natural gas. The Bakken Formation is one of them. If you fly, and we've done this, if you fly an infrared instrument over Texas, over the Permian Basin, it just looks like one big cloud from all the leaks of leaking methane that are going as a potent greenhouse gas, an important part of the problem. We got to plug those. That's low-hanging fruit. Also, it's jobs in order to do it. We have now, I'm happy to say that the current administration led the global methane pledge at the last climate conference in Glasgow in November of last year. And it's a brand new idea. It really is low-hanging fruit. We should have done it a long time ago, try to plug all of these methane leaks in order to reduce greenhouse gases. Methane only has a lifetime in the atmosphere of 12 years. So if we could reduce methane concentrations, we could get a big improvement in climate and warming almost immediately. Well, of course, you know, we're kind of suffering from whiplash here in our country, but Obama rejected the Keystone XL pipeline, shown here coming down through, it would have come down through Nebraska and eventually down to the Gulf Coast. It would have carried very dirty coal oil. We call it bitumen. It's almost like an asphalt, but it will flow through a pipeline if you heat it up enough. And from the tar sands in Alberta to Illinois. And so Obama rejected it, Trump approved it, and now I think it's killed for good. I have to ask the question, why would we build oil infrastructure that's going to last 50 or maybe even 75 years? Why would you want to invest in that kind of infrastructure knowing that we cannot possibly burn it? If we burn all of the oil that's in proven reserve, there's about $4 trillion. We're talking about a big stranded asset. If we burn all the oil in proven reserve, we will have much, much more serious climate damages, sea level rise, wildfires, loss of species, and ice melting. We can't do it. We have to keep it in the ground. The Dakota Access Pipeline should have never been built. You probably read about it for the same reason that we're just talking about it. It did go from the area in North Dakota. I showed you the Bakken Formation of shale, very tight shale, which now through new technology really developed here in the United States by wildcat small firms. The technology involves two breakthroughs, happened about 20 years ago or so. One is to frack, to use high pressure to break open the shale, which holds the oil that was never available before. And the second one is directional drilling. You can drill one hole down and go out with spokes like a wheel, miles, at least a mile, so you can harvest a lot more oil from a lean formation. And that's why our country is now basically energy independent. basis, we import about less than 20% of our crude oil, but we're the nation's largest exporter of refined oil products. So a lot is going out. The world's largest exporter of refined oil products, because we have the refineries in the Gulf, and we do still import some, but it's rather small now. We just stopped the Russian oil purchases, as you may know. So in general, Congress and EPA have been very kind to this new technology called fracking and directional drilling, but that could change. We have something on the order of 300,000 fracked wells in the United States already, and they're producing about 4.3 million barrels a day. But they leak, at the very least, if we're going to utilize that resource, we're going to have to plug those leaks, as I mentioned before. Some more good news came out of Glasgow last November, but I have to admit that it's not enough. More ambition is needed. We need greater pledges from all countries. Everybody has to participate to lower their greenhouse gas emissions. We can't treat the atmosphere as an exhaust pipe any longer. And the goal is 45% reduction of emissions by 2030. Gosh, that's only 8 years away. We have to move fast and be transitioned out of the fossil fuel age by 2050. My students, I tell my students, you know, the fossil fuel age, it's been a good run. Ever since the Industrial Revolution and the steam engine was invented, for over 200 years, we've powered our transportation, we've used it for all our manufacturing, we've built all our habitation, everything with fossil fuels, and it has been a blessing and a good run. But now we've run out of time. It's not that we're running out of oil and natural gas and coal, by far not. We can't burn what we've already discovered, or we're going to get much, much hotter. What we've run out of is a place to put the emissions from that. And that's because greenhouse gases are radiatively important. It's like wrapping that atmosphere that we looked at in the first slide with a blanket, because those gases absorb back radiation from the Earth, and that's what makes us so much warmer. Some of the crucial issues at Glasgow that we discussed are shown here. No need to go into all of them. One I already mentioned is the Global Methane Pledge, which I think is just brilliant, and the United States and Biden and EU led that program. We still have to do it. The Global Methane Pledge, you can see here the problem. I remember when I first started teaching about climate change, I said, well, at least we don't have to worry about methane. It looks like it's finally leveled off here in the 2000s, but up and up it goes again. We don't know for sure why. It could be due to the leaks that I mentioned earlier, because we're producing a lot more oil and gas, especially from these fracking operations. It could be due to melting of permafrost, like in Alaska, because at the bottom of the permafrost is ice that's composed of methane. They call it clathrates. It could be due to more and more people. We're 8 billion people now. More and more people to feed, and we use rice in part to feed, and rice is like each rice plant's like a little smokestack with its roots in the soil, creating methane and then putting it into the atmosphere. It could be because 8 billion people need more and more mouths to feed. We have more and more animals, and the manure from the animals, and if it's a ruminant, the belching from the animals too. Whatever is the cause, it's rapidly increasing. It looks like it's accelerating. So this Global Methane Pledge is a very important good news story that came out of the Glasgow meeting with the US and EU leading it. Methane is about, on a molecule per molecule basis, about 25 times more potent than carbon dioxide. So we really need to get a handle on that one. I'm proud to say that one of our former students, Marcelo Mena from Chile, here at the University of Iowa, all his master's and PhD from Iowa, here we're shown as delegates at the United Nations meeting in Paris in 2015. He was the representative and the environment minister from Chile. Now he's been named the CEO and head of the Methane Hub, a $360 million, $30 million philanthropy to get a handle on methane that we've been talking about. So it's got a University of Iowa connection through Marcelo. He's marvelous. I don't know if this is true, but I'd like to think maybe we've reached our end of our fascination with the fossil fuel age. I get a kick out of this photo here from the 1960s. I lived through that. I don't remember gas-powered roller skates. Do you guys? But at least this photo shows that. Maybe we've lost our fascination. We've had energy policy. It's burn whatever is cheapest. That's been our energy policy. And when you transition out of fossil fuel and create all these good paying jobs, it's going to have to transition away. Remember, wind and solar are free. Wind and solar are free. Nobody owns the sun's rays that come down. Nobody owns the wind. We don't have to fight any wars. We don't have to protect any supply lines for oil and gas like we presently do. This is the way we have to go. It'll be a much, much better world as a result of that transition. Well, you may have heard that we need to adapt and we need to mitigate. Mitigate means stop the emissions. Adapt means we're going to have more climate change for sure. It's going to get worse before it gets better because the climate system has a long timeline associated with it. And in adaptation, we try to at least respond to that increased global warming, increased changes in climate that we're bound to have just as a result of what we've already emitted. The carbon dioxide from burning coal, oil, and natural gas lasts more than 100 years in the atmosphere. So it takes a long time to reduce our emissions and begin to decrease those concentrations. Hardening our infrastructure is one way to adapt. That means raising all substations and utilities out of the flood zone. That means raising roads, bridges here. Floods are the biggest manifestation of climate change for us here in Iowa is flooding, and we need to adapt and invest in our infrastructure. We are. Iowa City has already invested over $100 million following the 2008 flood. So we are investing, but we have to continue to invest more. What does that mean? Jobs for our kids and our kids' kids. Regenerative agriculture is something that Iowa can do more about that in a moment. We need to conserve and reuse our water, protect our groundwater supplies. We think of ourselves as water rich. We are, but we're pumping down our aquifers even here in Iowa beneath our feet. And eventually, that's unsustainable. Eventually, we'll have to come to grips with that. We need kind of a circular economy. You know, I showed the Tesla manufacturing facility in Shanghai. And Tesla's, if we had truly believed in a circular economy, I guess maybe we would have never even allowed a Tesla to be sold. Because at the time the first one was sold in 2007, we had not a clue how to recycle that lithium-ion battery. We're still, Tesla claims it's at now about a 50% recycle rate. When you use up the battery in a Tesla, and we haven't much because they're all so new, but when we use it up, it has a capacity of about 70% still electrical storage capacity in kilowatt hours. That's not enough to run a Tesla, but it is enough to maybe use those batteries, and we're talking about in a typical Model 3, something on the order of 2,166 batteries, much like the battery, just the small disk battery in this laptop. Much like this battery, I put my phone away, but in a phone. Tesla figured out that it was genius. They were the first ones to figure out how to put 2,166 small lithium batteries into a battery pack and keep it cool by air cooled. That was the big leap in technology. And they went with the small lithium-ion batteries from laptops and phones because it was a proven technology. And it was proved to be a really good way to go. In a circular economy, you don't build wind turbines with blades that you don't know how to recycle. That's our situation today as they come up. In a circular economy, we've got to figure out how to recycle everything. Yes, we can use in a hybrid car a nickel-metal hydride battery as long as our recycle rate starts to approach 100%. Then you don't have to mine anymore. You don't have to foreclose the ability of future generations to live their life as comfortably as we do. So what I'm trying to do, you can probably tell, is imagine how good the world could be if we really do respond to these climate challenges. We need to, carbon dioxide is now about 415 parts per million in the atmosphere. It started out in the industrial age at about 280. So it's gone from 280 to 415. And our models indicate that we need to go at least back to about 350. We need to turn it back. So first level off emissions, and then it'll be a couple decades before they decrease again to 350, and then we'll have a stable climate. So that's the chore before us. Mitigation is to how to reduce those greenhouse gas emissions. We need to drastically reduce them. Again, the goal is 50% in 2030, 0 by 2050. We need to replace the fossil fuels with wind, solar, biomass energy, and so on. I include nuclear too, but I'll be honest with you, nuclear isn't going to help us with this 50% reduction by 2030 because it takes at least 10 years to site and permit a nuclear power plant. Now, the next generation of nuclear power we think will be much, much safer even than the existing. There have been essentially no deaths caused by nuclear energy. It has a very, very safe history in our country. There was the Chernobyl disaster and the Fukushima disaster, and we can talk about those if you want to. I believe we can store our nuclear waste safely in deep geologic disposal, but we need to get on the dime in order to actually do it. We need the will to actually do it. So we already have a lot of nuclear waste anyway. Maybe nuclear is a part of a low carbon, almost no carbon baseline energy in addition to the intermittent wind and solar that we're talking about. It won't help us with this near goal. Maybe in the farther out goal, it could be a part of the story. We need to electrify almost everything. So we like gas stove because, you know, it heats up evenly and quickly, but maybe an electric stove isn't so bad after all. We use gasoline in our cars. Maybe an electric car or at least a hybrid electric isn't so bad. Everything in electricity can then be produced by wind and solar. Free fuel. that's the way to go. We'll use renewable wind, solar, maybe nuclear. We'll have electric vehicles with battery storage. It's coming on strong. More charging stations to make it very convenient. We have to change and build out our grid to transport the electricity, weatherize our homes, and again, jobs, jobs, jobs. One of the things that in my research we work on is reforestation. I also use plants to try to help clean up the environment. But to me, this is just a no-brainer. We still have lots of land, marginal land or degraded lands that need to be reforested. And as these trees grow, they take carbon dioxide out of the atmosphere and store it into woody biomass and even into soil organic carbon, replacing that valuable soil organic carbon. When the forest reaches a climax, maybe like shown here, say 100 years or so, you're going to have to harvest it. And either get rid of the woody biomass, maybe in the bottom of the sea, or in my proposal, you would turn it all into biochar, because you store it then as carbon and use it as a soil amendment. So we would harvest the trees, turn them into biochar, and of course replant. Because once the forest meets climax, it's not taking out carbon dioxide anymore, it's net zero. Then you have to start over and over and over. And we'll continuously remove carbon dioxide from the atmosphere. I would do it on marginal and degraded lands, and yeah, we'll talk about agriculture here in a minute. The biochar is shown here. It's a technology that goes back to Brazil and the Amazon 2,000 years ago. It's shown between rows of, I think this is lettuce in this particular application. It takes more carbon dioxide out of the atmosphere to grow the biomass than when you burn it under, when you burn the carbon material under low oxygen conditions, pyrolysis, only about 50% is returned. So the net carbon dioxide benefit is roughly half of it is stored in that biochar material. Massive reforestation, there are projects going on, good news. In the Sahel, something on the order of 20 African countries with the help of others have begun to replant the sub-Saharan desert, which used to be treed and forested, but could be returned with the right techniques. And this is the project called the African Union Project going on right now. Here's the Sahara Desert. China once had a great green wall. Now they have just the Gobi Desert and sand blowing into Beijing. This whole area could be replanted and reforested to take carbon dioxide out of the atmosphere. We have lots of marginal lands also. Iowa used to be about 75% of our forests have been cut. Most of the forests were in the stream margins in Iowa. And we could begin to replant those areas as well. The regenerative agriculture, we can play a large role just by, we've lost roughly half of our topsoil since pre-settlement. Settlement here was began in about 1832. I know of a century farm on the English River that's deeded in 1832 and been in the same family the whole time. So unfortunately, every time you look up on a hill and you see kind of brown-gray, that's where the topsoil used to be and has washed away. We've lost, about half of it. It used to be about 2 feet of black topsoil in Iowa. Now we're down to less than a foot. And again, that's unsustainable. It can't continue forever. But we can help to solve the climate problem by so-called regenerative agriculture, such as shown here, low tillage or no tillage, very few pesticides and chemicals, cover crops in the winter rye. It's better to plow it back in. Right now what the farmers are doing is they're herbiciding it and then plowing it back in. I would just plow it back in. Managed grazing. We have to put animals back on the land. You do see cattle still in fields in Iowa. You don't see any pigs. We have 22 million pigs right now. When was the last time you saw a pig? You know, think about it. We have 3 million people and 22 million pigs. 8 times more pigs than people, and you never get to see one. And my friends in Minnesota say they can't tell the difference anyway. We need buffer strips along the stream margins, grass waterways in between, and even let's replant some prairie too. We've lost about 99% of the prairie in Iowa. Wind power is an Iowa success story. Some of the wind farms are shown here in this map schematic. We are now a leader on a per capita basis, per person basis, and on a percentage of our electricity demand in Iowa with 11,000 megawatts of power. That's 11 gigawatts, 57% of our demand, and we're second only to Texas in total wind power capacity. Tesla electric vehicles, my students get excited about this one, the Model S. Can you imagine? I once got to drive a Ferrari Testarossa, and it's quite an experience, but can you imagine going 0 to 60 in 2 seconds? They would just snap your neck off. You know, the torque goes 100% immediately to the wheels. And so very quick, very quiet, very fast. My biker friends hate them because you can't hear them coming. But this is the Model S, kind of pricey. My students can't afford it. I tell them to study harder if they're interested in that one. And here's the one that most of us are buying, the 2021 Model 3. It's a little bit more affordable, still pretty pricey. It's got a remarkable range for an electric car on the order of 300 miles, and so we can get a lot of places on that. This is one I thought I'd show you because it's pretty interesting too. They're on order now. You can't get them on the lot, but the Toyota has taken an interesting strategy. Chevrolet that's going to go all electric, and they're not investing in hybrid cars very much anymore. So each company seems to have a different strategy. But Toyota's strategy is that for a long time, we'll have plug-in hybrid electric vehicles. These count as electric vehicles in the current EPA definition. And so if you're using your vehicle to go to work, 42 miles is a pretty good amount of, you can use it just as an electric vehicle. But if you have to go visit your cousin in I don't know where, Ohio, the 400-mile range on a gasoline motor kicks in, and that's pretty darn good. EPA estimates for typical driving for a typical energy mix about 104 miles per gallon equivalent. That's figuring most of the time you're using electric and some of the time you're using the gasoline. Maybe this is the future. My students get excited by this too, the hydrogen fuel cell vehicle, because nothing comes out of the tailpipe but pure water. The problem is you can't mine hydrogen. It's just an energy carrier. You have to make the hydrogen somehow. Right now, the way that we're making it is we take the hydrogens off of methane, CH4, in a steam reforming process. But then you've got the carbon left over, and you need to deep six that into some kind of geologic repository or something such. So we also don't have any hydrogen fueling stations except in California and DC, I believe. So a lot of infrastructure would be needed. There's some ideas if we move towards a hydrogen economy. Of course, the space shuttle and all of the spacecraft all run on hydrogen. It's all the appliances and so forth run on hydrogen. So the technology is there, but how do you make the hydrogen is a big question. And ideally, you'd use, you might remember from your high school, the electrodes, if you put 2 electrodes with a battery in the water, you make hydrogen at one electrode and oxygen at the other. And that is one way we can make hydrogen. If you use membranes, that's about 8% efficient, thermal efficiency, not very good. But if you use membranes in the process and make like a fuel cell out of it, you can get a much higher efficiency. And when, if you're running a wind and solar, let's say wind at night, you might be surprised in Iowa, the wind actually blows more at night than it does in the daytime. We don't need much power at night. So you could do electrolysis, we call it green hydrogen. You could do electrolysis at night in off-peak hours, make hydrogen, and that would be another way to make wind power storable, overcome its intermittency. These vehicles have a 400-mile range. Hydrogen is the lightest element known. It's number 1 on the periodic table. And to liquefy it, you need about 900 atmospheres of pressure. So what they're doing right now is they're doing about 400 atmospheres pressure and compressing it. And for that, you have a reasonable 3/8 of an inch steel tank will do that. To turn it into liquid would require much more pressure, and any higher pressures would require a tank too thick and heavy for any reasonable vehicle. So again, the theme is high quality jobs. This is the transition which is going to be the economic engine for development in the future. And we've talked about, I think, just about everything here now. Solar photovoltaic power plants, PV. This is one of our larger ones shown in the Mojave Desert in California. It's 550 megawatts. The beauty is coastal desert has no water. They have way too many people for the water that they have right now. But these don't require much water, only in the manufacturing. Right now they're being manufactured mostly in China. And so 550 megawatts, another beautiful thing about it is it scales. If you have more land in the desert and you need twice as much energy, you just do twice as much land and you get twice as much power and energy. It's pretty cheap now, 6 cents a kilowatt hour. We're paying about 10 cents a kilowatt hour. Mid-American would like that to come down to about 0.02 for them to invest, but wind is cheaper than this still, so they prefer to go with the wind right now. There are disadvantages, of course, mentioned here, the large land required for a desert. There might even be species there, desert tortoises or other endangered species, which limit to some degree these solar power plants. Do you think we need these in Iowa on ag land? It's a current topic of discussion. Maybe we'll open it up for discussion. Battery storage is getting cheaper. This is, again, Elon Musk has a battery storage unit, such a deal. He can sell you for a 5 kilowatt power unit for, you can have 2 batteries, 5 kilowatts each, which would be plenty of storage for your house, but it's going to cost you about $30,000. And here you can see it on the side of a house. Batteries are coming down in price. Maybe someday, if you're off grid, this is ideal because you're not on the grid, so you have to store your solar PV on your roof in batteries like this. But his idea is everybody should have this, and then you're not vulnerable to like the derecho, when we had 400,000 people lose power for two weeks. You're not vulnerable to any of that. And also you can store your own solar power in the battery. Maybe more important though to our discussion tonight is utility scale storage shown here. This is again to make a wind farm or a solar PV facility like I showed earlier to store it. And maybe we could use spent Tesla batteries. In fact, there are a couple sites now that are trying to do that. Remember, when they're done with life in the car, they still can hold 70% of their charge capacity. That's plenty for storage at a facility such as shown here. The biggest one right now is at Vistra Moss Landing in California. It's about 400 megawatts. It just uses those tiny lithium-ion batteries again in order to store it. It would be a way to recycle those batteries much more efficiently. Solar farms in Iowa. So you can make a lot more money from solar farms in Iowa than growing corn. I can prove that to you, I think. But should we? You know, maybe food is the highest use. Of course, of the 4 F's that farmers provide us: food, feed, fiber, like cotton, and fuel. We're only doing feed and fuel, right? About 50-50 for corn, 50% fuel and 50% feed for animals. There is also other benefits like dry distiller grains associated with corn ethanol. 1 megawatt requires about 4 acres, shown here, and that's just assuming a cheap crystalline solar power module without tracking. CO2 pipelines for Iowa. I'm kind of leading into all the controversial issues to try to get some good questions going here. Here's the Summit Carbon Solutions. If you believe that corn ethanol is going to be around for a while, I do actually. And I also think that biorefineries are one of the technologies that we need to pursue quite avidly, because you know, even if we electrify almost everything, we're not going to put solar panels on our airplanes, are we? We're going to still need some liquid fuels. We're not going to put solar power on our shipping, probably not. We're still going to need some liquid fuels. We could grow those liquid fuels with good old Iowa soil and rainfall, and then make a refinery and turn it into the specialty chemicals that we need. That's part of the transition that we could partake in Iowa. The 3 pipelines, as you may know, are Summits, Navigators, and Wolf Carbon for ADM in Cedar Rapids. I didn't show the pipeline that already in Decatur, Illinois. They are deep sixing the carbon dioxide from ADM, corn sweeteners, in deep geologic disposal. They have an old coal bed there that is almost ideal for storage of carbon dioxide at liquid. So you compress it to a liquid, you put it deep, and hopefully it stays there for thousands of years. And so this is thought to be another solution to make, for example, corn ethanol is already better than gasoline. On a life cycle basis, EPA says it emits 20% at least lower greenhouse gas emissions than petrol gasoline. However, in order to do that, 20% really isn't good enough for the future. We need to have 50% by 2030, 100. So we need to make, if we're going to do corn ethanol in the future, we got to make it greener. And this is a part of making it greener, because fermentation reaction, when you take corn kernels that are just a little kernel of starch, really, the first thing you do is hydrolyze it. That's easy as can be to turn it into sugars. Then we ferment the sugars to turn them into alcohol, the ethanol for transportation fuel. And the carbon dioxide from the fermentation is a pure stream, 90% or more carbon dioxide. It's an ideal place to collect carbon dioxide. I have a student that just graduated who we have been taking carbon dioxide out of power plant, coal-fired power plant stack gases. In fact, we've simulated the stack gas at the University of Iowa, and we grow algae. We bubble it through and we grow algae with that carbon dioxide. But it's only at best about 14% CO2 in the stack that's coming out of Burlington Street plant. These corn ethanol plants are almost pure CO2. It's an ideal place to condense it into a liquid and put it in a pipeline and ship it off. So the question kind of comes down to, if you believe that corn ethanol is going to be a part of this future, then we've got to make it greener. We have to. And these pipelines begin to make sense. Some of the opposition to them is that they will really be a good investment for these companies shown here, because the federal government has so much tax credits associated with making this industry greener. They will make money in 2 years, payback period, with this investment. But farmers have kind of lost trust in the pipeline solutions, kind of because of the oil pipeline. The Dakota Access Pipeline has to run hot. Those are hot to keep the oil flowing in a liquid form. These will run cold because it's got to be compressed CO2, and it'll go up to, in this case, the Summit one will go up to the Bakken Formation that I showed you earlier in North Dakota. They swear they're just going to deposit it geologically deep, and that'll deep six the CO2. Remember, right now we're putting it in the atmosphere, right? Then we're going to put it in geologic disposal with the idea that it'll stay for thousands of years. Whereas in the atmosphere, it keeps heating up the atmosphere. So those are some of the pros and cons. Eminent domain has become a nasty word. It is a taking, right? If you don't want to sell, and the Iowa Utilities Board declares on eminent domain, they can give you a market price for the easement of that land in perpetuity. They own that easement, they can even sell it as well. So maybe I've gotten more, but I think we'll pause here and leave you with these questions we just asked. Should we allow developers to build solar photovoltaic farms on Iowa agriculture land? Remember, food, feed, fuel, and fiber. What's the most important? A lot of people would say food. That's one thing. Solar, I made these calculations before I came over tonight. Solar, by my calculation, is 4 to 10 times more profitable per acre. So there's going to be a lot of people looking at this. In Iowa, an acre of solar panel will produce about 200,000 kilowatt hours each year. That would allow you to, for 1 acre, you can make, with ethanol, say you get 200 bushels an acre of corn, that's about 2.8 roughly gallons per bushel. A 54-pound bushel of corn will make 2.8 gallons of ethanol, and that 2.8 gallons will drive your car a few miles, but not very much. The electric power would drive your car 700,000 miles. So you get about 200 times more energy per acre from solar photovoltaic panels than you would from corn ethanol. So if you want to make transportation fuel, and you want to make, and you do it in the form of electricity, it's a lot more efficient than turning corn into corn ethanol. Second question, should we adopt policies to encourage corn ethanol? Like, if you believe it's going to be continuing, it is an important part of the Iowa economy, no doubt, currently. Then should we build these CO2 pipelines, or should we turn the page on corn ethanol as kind of not a very good use of the land anyway? I'll leave you with these. I don't have the answers. I'm hoping that you guys can tell me what to do. If there's time, I can answer. Yes?
Jerry, circling back to methane,
Yes.
if we realize how much flaring and leaking is causing problems, and it's been largely ignored by,
Yes.
by the oil companies, I understand that the current money that has been allocated.
In the bipartisan bill.
Right.
Mm-hmm.
In that bill, why wouldn't we jump on that tomorrow?
I hope we will through this methane hub. And could we, why don't we, due to all the leaks that we know about from oil and gas exploration, why don't we jump on that tomorrow as a way to help solve this problem? I agree entirely with the question, and we should, and I hope with the methane hub we do. I'll tell a story, a short one, if you'll trust me. I wrote an article as the editor of Environmental Science and Technology called Regulate, Baby, Regulate. And I made the comparison between the Gulf oil spill and regulations and fracking. And I said basically that the industry isn't being regulated and it needs to be regulated. After that, I testified before Congress on really on the efficacy of the EPA. And Andy Harris, the congressman from Maryland, he was an anesthesiologist by training. He really believes he's a good scientist, and he tried to take me apart on this. He found this editorial that I'd written, Regulate, Baby, Regulate. And we got in a big argument. It's all, actually, you can see it, it's all online too, on C-SPAN. But most observers say that I won the argument. He kept interrupting me. You've got a little red light, and it tells you how many seconds you have to speak, but he kept interrupting my time, and that made it difficult. But the answer to your question is we need to regulate the industry. Yes?
Jerry, that's a wonderful talk. I haven't heard that for about a year that I've been gone. I've been gone out of state, and we've returned here to Oak Knoll a couple 3 years ago. That's a trip. Getting its vengeance on me, I developed Parkinson's from a paraquat probably. And likewise, there was a serious effect on my wife's nervous system as well. So we will pay for that for some of our progress, but it is wonderful to see that enthusiasm and ability that you bring to the floor. I would just point out that there are some other unexpected advantages from having more cheap power. One of them is we have an Iowa birth defects registry, and cancer registries are largely funded by these facilities.
The question is can I use the word externality associated with the way we do our energy today, and fossil fuels has to do with health defects and health effects. And there's a cancer registry which he mentions shows that there are consequences associated with this kind of air pollution. Is that a fair statement? Thank you. Yes?
Could you comment on solid-state batteries?
solid-state batteries are going to be part of the battery technology that allows us to have cheaper storage of wind and solar, and the technology is improving rapidly. We have people at the University of Iowa who are actually working on patents on that. Jonna Letty, some of you may know her in chemistry. She's got a bunch of patents on solid-state batteries already.
Jerry, I'm sorry, we're just going to have to stop.
Oh, okay. I'm sorry if I went too long.